Section 4, Machining. Almost every rebuild requires machining of some sort. The various equipment and specialized tools used in this process are not readily available to the average engine builder. This section will guide you through one of the most important aspects of the rebuild process. Tell the machine shop what you expect from the engine you're about to build, and they'll be able to help you decide on what is absolutely necessary and what is not, depending on your budget. For everyone, the first step is clean parts. Let's go inside and see how it's done.
Before the parts are examined beyond a quick visual inspection, they need to be cleaned. Our filthy pile of parts ended up at Edding's engine rebuilding, and here they even like to have all the little parts sent through the wash. Everything, from the block and disassembled heads to the crank and all the covers, were put into the jet wash for degreasing. After that, the heads and block were blasted or baked until they came out perfectly clean, and any of our external covers were detailed to be ready for paint later on. The machine shop is going to go through and check every part. This is a much easier job when everything is clean. Once all the grease is off, every part will be visually inspected for cracks or damage. After a visual once-over, the block and heads need to be checked for hard-to-see hairline fractures or cracks.
Any parts made of cast iron can be magnafluxed. For this process, an electromagnet is stuck on the part and then it's sprayed with a special powder that will stick to any cracks and make them very visible. Magnaflux doesn't work on aluminum parts. They need to go through a dye process to make cracks visible. Once the machine shop knows if the parts are still good and not cracked, they can measure the tolerances to see what machining is going to be necessary. If the visual inspection showed that there was obvious scratches or damage to the cylinder walls in the block, then the pistons would be considered junk and the block would need to be bored out. If the visual and the magnaflux of the block was okay, a dial bore gauge would be used to check the cylinders to see if they were out of round or if there was a taper from the bottom to the top of the cylinder. The dial bore gauge will tell the machinist if the cylinder has to be bored to straighten it out or if a hone is going to be all that's needed to clean up the cylinder walls. In either case, the pistons have to be measured. If it's a bore and hone job, new pistons are going to have to be used. The new pistons don't have to be on hand for the boring process, but they do have to be physically measured to determine the size of the final hone.
Piston size is a constant and cannot be machined. With the piston inverted, the skirt is measured here just above the pin bore. This will determine if a used piston can be reinstalled in a block with just a hone job. In the case of a new set of pistons, the diameter found with the micrometer will tell the machinist what dimension to hone the block to. This way, the pistons will have the proper clearance in the cylinders. If a piston is measured and found to be worn too far, it is considered a collapsed piston and cannot be reused.
Both cast iron and aluminum heads will get a close visual inspection. Some machine shops even have a vacuum fixture that can test how well the valve seats are sealing. The valve guide, which is the hole in the head where the valve slides, is checked for excessive play, and if wear is found, the valve stem might be checked with a micrometer to make sure the valve can be reused. For the valve train, the camshaft and lifters should be examined. Any signs of wear will indicate that all the lifters and the cam will need to be replaced. As we said before, it's pretty much a standard procedure to replace the cam and lifters for almost every rebuild. The valves and springs will get inspected a little bit later on. Any push rods that don't roll smoothly on a piece of glass should be replaced, as well as any keepers, retainers, or rocker arms that have signs of damage. Remember to keep everything in order if you're planning on reusing the same parts.
Back to the short block, the crankshaft is also inspected and measured. If there are serious scratches or gouges in any of the journals, they will need to be ground undersized, and oversized bearings will be used later when we reassemble. Bearing manufacturers usually limit available sizes to standard 10, 20, and 30 thousandths of an inch oversized for cranks that have to be cut. This crank was cut 10 thousandths under on the main journal and 20 on the rod journals. Now it's getting the final polish to make the journals as smooth as glass. Sometimes the final polish is all that's necessary to return an old crankshaft to a usable status. The big and small ends of the connecting rods will be inspected too, and the rod bodies will be checked to make sure they're not bent or twisted.
After all the inspections and measurements, your machine shop can give you the diagnosis of what machining needs to be done to your engine. We brought our shop a couple of prize winners. Our combination of parts needed everything in the book. 2 of the blocks needed a bore and a hone because of serious damage to the cylinder walls. Of course, this meant that all the pistons were junk, which was pretty easy to tell just by looking. One of the blocks had a misaligned main bearing bore, and another one had one warped deck, so both decks would need to be cut straight. Every cylinder head that we brought in the door was warped, and they needed valve jobs, and most of them had bad seats and guides. One of the connecting rod sets had spun a bearing. The rod passed the check for bent and twist, but it wasn't straight, and it had to be replaced. All of our other rods just needed resizing. The other few crankshafts that we brought in needed to be cut and polished to bring them back to a usable state. There are a few more parts to check, but that'll come later. Now the machine shop has enough details to know what to start with and has a list of any parts or replacements that they need to order for us.
The align hone of the main bearing saddle in one of the blocks came first. The main caps were removed and a couple thousandths of an inch were ground off the bottoms of the seats of the caps. Then the caps are put back on the block and tightened and torqued to spec. After being cut, the opening is no longer circular. It's a slight oval. The size is checked with a dial bore gauge, and the honing stones are inserted and expanded until the proper drag is felt. The honing drill is lined up with the stones, and once the oil starts to flow through the tube above the block, the stones are passed in and out while the drill is running. As this happens, metal is being removed, and the oval shape begins to return to a perfect circle. As the stones take off metal, the block and caps begin to heat up. The machinist checks the size with a gauge and then takes a break to let the block sit and cool so the metal will return to its true size.
After a few minutes of cooling, the stones are run again and the progress is checked with a gauge. Then the block is lifted and turned around so that the hone can be finalized to the perfect size from the other side. This is the first process for the block because the next 2 things to be done depend on a perfectly straight line through the main bearing bore for proper mounting to the machine. For decking, the alignment dowels for the heads are removed and the block deck is leveled. When the deck is perfectly level and the machine is started, it runs by itself at a set pace and shaves off a few thousandths of an inch to make the deck perfectly flat so that the new head gaskets will have no problem sealing out water, air, or oil leaks. When one deck is done, the block is rotated and the machine is set up again. Both decks have to be cut or there's going to be a difference in the compression ratio from one side of the motor to the other, and the intake manifold won't fit properly. This cut only took off about 5 thousandths of an inch. The factory number stamping of the block ID was even still visible. Using the same mounting point through the main bearing bore, the block deck is leveled in the boring machine. The machine needs to be set in the approximate center line of the first cylinder bore. Then the machinist tells the machine that it's a V8 and presses go, and the machine will take care of the rest for the first half of the block. This particular machine will then center itself in the bore, and then the cutting tool for the proper overbore size, which was already set up in the spindle, will go to work once it starts to spin.
This machine knows how far to go down in the bore for each engine type that is programmed into it. When one bore is done, it will retract the spindle and automatically move to the next bore and center itself once again. It will go through and cut all of the bores to size for this first side of the block. The block will then be lifted out and flipped to the other side to get finished. A piston bore that is still the original diameter, as when it left the factory, is said to be standard size. The normal increments for pistons that are manufactured for oversized bores are 10, 20, 30, 40, and 60 thousandths of an inch. The boring machine will cut the cylinder wall to a few thousandths of an inch shy of whatever bore you will need, and later, the honing machine will open it up to the exact spec.
We're still waiting for our pistons to be delivered, so our machine shop moved on to the heads, starting with the guides. First, the old tired guides got bored out a couple thousandths, and then nice new shiny bronze liners are pressed into the head. The excess of the new liners are sheared off the top and bottom, and then a steel ball, which is the exact diameter of a finished guide, is pressed through until it pops out the other side. This leaves a perfect size hole for the valves to slip into later. The head is now placed in a leveling fixture and set up on the decking machine. Our heads were set up so the least amount of metal possible was removed to make the surface flat again. The more metal you shave off the heads, the more the compression ratio raises in the combustion chamber, and the closer the valves will be to the tops of the piston when they open. Then the head was passed to the seat cutting machine, and this time it's leveled so that the valve guides are positioned straight up and down. Next, an example valve that has a perfect angle cut in it will be set up with a pointer. The position of the pointer is used to set the position of the cutting tool. After the cutting tool is set up and double-checked, the valve seat will be cut.
At Eddings, all valve jobs are the higher quality 3-angle valve job. The tool they use cuts all 3 angles of the valve seat at the same time. 2 of the angles are meant to smooth the flow of air in or out of the chamber, and the middle angle is the one where the valve face will contact. This is an intake seat being cut here. Setup is the same for the exhaust seats, except the exhaust seat areas are bored out so that hardened steel inserts can be used to handle today's lower fuel octane ratings. This cut with all the smoke is the inner diameter of the hardened seat being sized out. Then the actual exhaust seat is cut, all 3 angles at once. The size of the middle angle where an exhaust valve sits on the seat is much wider when compared to the intake seat. The exhaust valves get much hotter and need more contact surface.
After all this work is completed, a cylinder head is like a piece of art. Now that the heads are perfect and the guides are back to spec, the valve stems get mic'd to make sure that they're reusable. If they check out okay, the valve tip has a bit ground off to flatten it, and the valve is put in the machine to have the angle of the valve face freshened up. Valves come out of the organizer tray one by one, and the angle and the position of the grinding wheel is worked until all of the darker, dirty spots on the old surface of the valve face are returned to a nice, clean, and smooth ground finish. If a valve is put in the grinder and the grinding wheel is unable to contact the entire circumference of the valve face, the valve stem is bent and that valve is thrown away. Once the valves and seats are done, a valve is inserted in the head and the correct retainer is installed in place with a set of keepers. An installed spring height gauge or ruler is used to find the distance between the bottom of the retainer and where the spring is going to sit in the head. This measurement is the installed spring height. Once the installed height is known for the intake and exhaust, the springs are put in a spring checker and compressed to the size of the installed height. The integrated scale will tell the machinist the pressure, in pounds, that the spring is exerting at the installed height. If the pressure is not enough to keep the valve seated properly, sometimes a shim can be installed under the spring to give it more tension. If the shim isn't enough, the springs will have to be replaced by a new, stronger set that will close the valve properly with the correctly rated tension.
At this point, our new piston shipment has shown up, but we're going to deal with the connecting rods first, so the old pistons need to be pressed off the rods. This setup uses semi-floating piston pins, which means they are free to move in the piston, but they are pinched into a permanent position in the small end of the rod. You'll see what we mean in a minute. To remove a pressed-in pin, the piston is set in a special fixture, and a hydraulic press forces the pin out of the grip of the small end of the rod. Now that the rods are separated, the caps need to be removed. You might need to bang on these later to do the same. Only do this with a brass hammer. Next, the bolts are pushed out of the rod with the hydraulic press. We threw away these old tired bolts. Each cap is kept with its rod and, one by one, they are cut in the same manner that the main caps of the block were.
After the caps are done, the rods themselves are thrown in to be ground down a little as well. The grinding leaves a sharp edge that will have a tendency to scrape the backs of the new rod bearings when they're installed, so the edges are smoothed out with a file. Since we decided to install aftermarket rod bolts, the edge of the bolt holes need to be chamfered to accept the shape of the new, stronger bolt. Installing the rod bolts is actually part of the assembly process, so any metal shavings are cleaned out of the rods and caps, and the bolt holes are cleared to prep them for the new bolts. These rod bolts that are being pressed into the rods are made by ARP. Their bolts are far superior to any other bolt on the market, and we highly recommend you use ARP for any bolts that you're going to be replacing in your rebuild. They're especially good insurance for bolts that live as deep in the motor and take as much abuse as the rod bolts do. The threads will be lubricated and the nuts installed and torqued on each rod. With brand new bolts, the nuts are tightened and torqued and then loosened again, and tightened and torqued again a total of 3 times. This will break in the bolt and make sure that the proper stretch is achieved for all the bolts before the rods get sized out.
Now the bolts are torqued in place, but the shape of the big end is still an oval after the grinding of the caps and rod body. They're put one by one into the rod honer to return the big end back to a perfect circle. The size is checked frequently during the process, and when they're close to spec, they are left to cool for a bit. Just like the align hone on the block, the metal expands from the heat of the friction of the honing stones. Once they cool down, the job is finished, and the rods will all be within 1/10,000th of an inch of the specification for your motor. Larger machine shops might have a rod production machine. It can be set up to run off large numbers of rods in a short period of time. Eddings likes to keep dozens of rods on hand ready to go. So sometimes it makes more sense to buy a whole set at a good price with ARP bolts already installed instead of waiting for yours to be machined. Now the rods are ready for pistons.
If your pistons were reusable, they'll need to be cleaned. The machine shop could mask off the skirts with tape and blast off the carbon deposits. Doing this by hand pretty much just sucks. We recommend you have the machine shop clean any of your parts in a blast cabinet, especially if you have reusable pistons. The second best thing to do is just get an engine kit that'll be complete with a new set of pistons and everything else you'll need for down the line. All of our pistons need to be fit into their connecting rods now. The pin bores are lubed up and the pins are set in one side ready to be pushed through. The piston and pin are set in a fixture and a rod is set in a rod heater. With semi-floating piston pins at room temperature, the small end of the rod is too tight for the piston pin to pass through, but when the end of the rod is heated up, the opening will expand. Then the rod is held in place and the pin can pass through the temporarily larger opening in the rod. This stopper on the back of the piston holding fixture makes sure that the piston pin stops in the right position. This is not a simple procedure. The rod has to be facing the right way on half of the pistons and the other way on the other half, and if the pin's not passed through quick enough, the rod could cool just a bit and the pin would get pinched too early, and then they'd have to go back and press the pin out and try again.
Just before they were fit to the rods, the pistons were measured so that the final bore size could be determined for the hone. When the diameter of the piston is known, the machinist will know the exact size to hone the cylinder walls to. The hone will do 2 things. First, it will size out the cylinder bore to the exact spec that is needed to give the specified amount of clearance between the piston and the cylinder wall. Second, it will leave a fine crosshatch pattern of light scratches on the walls of the cylinder.
As the stones go up and down in the cylinders, the machine flashes a light when the stones are at the bottom of the bore, and a meter tells the machinist how heavy the load on the stones is. The balance between the speed of the stroke and the load on the meter is what will return the cylinder to a perfectly straight and round bore. A dial bore gauge is used a lot in the honing process. When the size of the bore reaches a specific point, it'll be time to change to a finer grit stone to slow down the metal removal and provide a smoother surface. There are 3 grades of stones used during the honing. When one side is complete, the block is flipped over and all 3 grades of stones are used for the other side of the block. When all the cylinders are at spec and within 1/10,000th of an inch, the stones are changed out for some brushes. The brushes will be run with the honing oil to clean as much of the grit out of the cross hashes as possible before the final wash. After the hone, the block is ready to go.
Once the cylinder bores are at their final sizes, the new piston rings need to be checked. Many ring sets come out of the box, appropriately sized for the bores based on the diameter measurement of the cylinder bore. The concern is that the gap in the ring must be at a certain specification when it's installed on the piston and inserted into the bore. To check this, a ring is fit into the newly honed cylinder. A piston can be used to square up the ring as it's pushed down into the bore. A ring installed in the second groove of the piston will act as a stop so that the ring doesn't get pushed too far down. The specified ring gap can be found in a repair manual and would be checked with a feeler gauge. Some types of rings are called file to fit or custom gap rings. The gap will be too small at first and will need to be filed until the gap is the right size. One side of the ring can be filed by hand. Just be sure to move the file towards the inside of the ring only. The gap of the unfiled side needs to be square with the filed side as well. The ring can also be placed in a hand-cranked filing machine to speed up this process.
A lot of machine shops can do all this for you. Many of them have powered machines that can do this job very quickly and precisely. Doing it by hand is a tedious process. If you do have custom fit rings, just make sure to keep them in order and labeled as they're cut to fit. They'll need to match back to the exact bore that they were filed to fit into. Once your rings are set and the machine shop is ready with all your other components, everything will need to have a final cleaning, if they haven't done it for you already. Hot water and soap do a great job. If you do the final washing yourself, make sure to blow everything out really well with compressed air. Machined and regular metal surfaces can be kept from rusting with regular applications of WD-40. Spray some inside everything too. The WD name stands for Water Displacing Formula number 40. It'll actually force moisture out of the pores of any metal and prevent corrosion. Now every piece of your engine should be like new. Get everything organized back at your workspace and we'll start the assembly.